Hello everyone, in this lecture we're going to learn about poka-yoke or error proofing, and this is an important principle that can help us eliminate muda or waste or defects in our processes. So the learning objectives of this lecture are to define the term poka-yoke, understand the motive behind poka-yoke, classify the different types of poka-yoke methods, and define what a good poka-yoke inspection device entails. Poka comes from a Japanese word meaning blunder, mistake, or error, and yoke is a Japanese word meaning protect, repel, or avoid. And so together we get poka-yoke or error proofing. And so poka-yoke is a mechanism or technique for eliminating defects. And what this does is it either prevents, corrects, or alerts to a defect in our products or information. And the idea behind it is that it relieves cognitive loading on people when making inspections, that is MURI or overburden. It reduces the need for post-inspection tasks, muda. So one of the 7 wastes, this would be considered over-processing. And also it reduces defects. And again, this is one of the 7 wastes itself, muda. So what are some common responses to human error when they occur? Well, when someone makes a careless mistake, we tell them to pay more attention. Someone forgets their training, we tell them to do more training. And I've seen this happen in industry when problems occur. Someone didn't follow the procedures, we make the procedures even longer. So we try and address this with even more bureaucracy. We didn't see the signage, we put up more signs. Someone falls asleep, then we fire them. But the problem is, what will prevent this from happening again with the same person or someone else? You know, none of these responses really get to the root cause of the problem that's occurring. And this is where poka-yoke comes in. So you're probably wondering why we call it error proofing and not idiot proofing. Well, calling someone an idiot is a pretty derogatory term. So it's a bit taboo in the idea of lean production and the Toyota way. And as the famous quote goes, to err is human. You know, this idea of people being fallible has been known for centuries. This is a quote from Alexander Pope in the 18th century on an essay on criticism. And also human error is really well understood in cognitive science, and it's very well understood and applied in aviation and the military industry. And again, one of Toyota's management philosophies is respect for people. So this is why we use the term error proofing instead of idiot proofing, and it also leads to the idea that we should blame the process, not the person, for the error. So Shigeo Shingo gives a categorization of poka-yoke methods in a book on a study of the Toyota production system. So he divides poka-yoke into regulating functions and setting, or as Don Norman would say in his book, a forcing function. So regulating functions involve a control type poka-yoke method, and this involves stopping the process until the problem is fixed, or jidoka. And then there's a warning type, so alerting the operator of a problem when it occurs. So obviously a control type is better than a warning type poka-yoke, but again, it depends on the cost of investment involved. So within the setting or forcing functions, we have a contact type poka-yoke device, and this involves detecting defects through physical abnormalities. This could be size or weight or color of the product. And then a fixed value poka-yoke device constrains the number of actions taken. So you can't do too little or too much. And then we also have a motion step. So this type of poka-yoke device constrains the sequence of actions that we can take. So what are 3 good rules for a poka-yoke inspection device? Well, first, we have to have 100% inspection rate. So all parts going through a process must be inspected. We have to have 100% success rate. So any and all defects must be detected. And in statistical terms, this is called sensitivity. And lastly, it must be low cost. So the cost of the device must be less than the cost of defects for a return of investment. So let's look at a really good example, power outlets. So this is something everyone's familiar with. The unique shape and arrangement of the pins constrain what type of socket or power outlet it can be applied to, and this prevents a wrong device being connected to the wrong power supply and damaging your electronics. So this is what Shigeo Shingo would call a setting or contact type Poka-Yoke device. And it obeys the rules of a good Poka-Yoke device because 100% inspection rate, so yes, it's applied to every sort of plug. It's 100% success rate, so you definitely cannot plug the wrong device into the wrong outlet. And it's low cost, so it's built into the design and manufacturing from the start. Here's another good example, car ignition. So how do we start a car? Well, the sequence of events involves first having your car in transmission in P or park. Then we have to insert the key, and then we turn the key to start the engine. And so this ensures the car does not move when the engine starts, but it also ensures the engine cannot be started erroneously. So a lot of new cars now don't have this kind of key ignition, but it relies on the proximity of the driver being in the car with the key to push the button. So Shigeo Shingo would call this a setting or motion type Poka-Yoke device because it constrains the sequence of actions. And it also has a 100% inspection rate. So every time you start the car, you have to follow this sequence. Usually it works 100% of the time. And it's also low cost because it's built into the design itself. So in this lecture, we learned about the definition of Poka-Yoke, and we looked at some examples of Poka-Yoke devices. And in the next part of this lecture, we're going to learn a bit more about cognitive science of human error that can help us design better Poka-Yoke.